All right, so we've talked about most of the things that you need to know. We've talked about parallel vectors, we talked about unit vectors, we talked about scalar multiplication, we talked about adding, we talked about subtracting, we talked about all those things. We talked about unit vectors and the idea of ijk versus component form. We've talked about 3 dimensions versus 2 dimensions, how to add and subtract, and all those things. And again, it's a lot of material, but it's really not that hard to understand in terms of what you've already done, because you already know some of that stuff. So we're going to practice, and tomorrow's class will be spent practicing. Each day that we present material, we'll practice. But I want to just talk to you about one last thing, which is the scalar product or dot product of 2 vectors. So really it has to do with your 4 basic math operations are adding, subtracting, multiplying, and dividing. We've added and subtracted already, but the question is, how do we multiply? All right, how do we multiply vectors? So we've talked about how to multiply by a scalar, but what happens when we multiply a vector by a vector? Okay, and what happens is you get one of 2 things. You can get the scalar product. Okay, the scalar product just gives you a number, and that number tells you something about the vectors. If you multiply the vectors together and get a particular thing, when you get a vector product, it will, or a scalar product, it will tell you something about those 2 vectors. And what it really allows us to do is find the angle between those 2 vectors. So that's what the benefit of the scalar product is. If we do a vector product, we get a vector. You guys don't have to know anything about the cross product or vector product, but the dot product or scalar product you do. So we're going to talk about the dot product, okay? And so we understand what that is or how we do it. So here's the definition. The scalar product or dot product is just taking each of the components, multiplying them together. So just like adding and subtracting, we take the components and add them together, and we take the components and subtract them. Well, here we take the components and multiply them together. But then once we've done that, we just add them all up, and it gives me a number. So the scalar product of 2, 3, minus 1, and minus 1, 0, 2, you would go 2 times minus 1 plus 3 times 0 plus minus 1 times 2. And you can see that I've written it out here. And then you just evaluate that. So minus 2 plus 0 minus 2. So you get minus 2, and that's minus 4. Okay, now what does that do for me? We'll talk about that, but that's how you do, that's the mechanism of doing the scalar product. All right. If you're doing it in 3 dimensions, that's how you do it. If you're doing 2 dimensions, obviously you just multiply 2 of them. But what's interesting about the scalar product is it gives us an idea of the angle between the 2 vectors. So if we think about how do we get the scalar product, if we have a vector v and a vector w, this vector here has length w minus v, because if we took w and this is, when we subtracted v from it, we would end up here. Okay, this, like, because v plus this vector is w, if that makes sense, which hopefully it does. So we have w minus v, that's the length. If we use the cosine law then, and this might need a refresher for you, but the cosine law is c squared equals a squared plus b squared minus 2ab cosine c. So we do the magnitude of this side is the magnitude of v, or w minus v. Then we have the magnitude of v, we have the magnitude of w, and we have then 2 times the magnitude of v times the magnitude of w times cosine of theta. That's the cosine law. And then if you think about w minus v, it's this, right? Because it's just w1 minus v1, so on. So that squared, w minus v squared, is actually this squared plus this squared plus this squared. That's the magnitude, right? And that, because the magnitude, you remember the magnitude is the square root. So if you square a square root, you just get what's underneath the square root. So the magnitude of w minus v should be the square root, right? We should have a square root over all this. But it's squared, so that removes the square root. And then v, the magnitude of v squared, again, the square root goes away, so you have v1 squared plus v2 squared plus v3 squared. W is w1 plus w2 plus w3, they're all squared. And then you have this. Okay? If you expand these, this jumps pretty quickly to, it simplifies to this. If you expand each one of these, you get w1 squared minus 2 times w1 times v1 plus v1 squared. Okay, then you get plus w2 squared minus 2 w2 v2 plus v2 squared. all right? And then you get plus W3 squared minus 2 times W3 times V3 plus V3 squared, okay? Now you're looking at that equaling this side. And what you'll notice is V1 squared, V2 squared, V3 squared, W1 squared, W2 squared, and W3 squared are all on here. So V3 squared cancels, W3 squared cancels, V2 squared cancels, they cancel. These guys cancel, okay? And then you notice that each of these terms that are left, this term, and this term, all have a minus 2 in them, right, at the front. And this is a minus 2 in it. So if you divide out the minus 2, that's how they get to here. But this is the definition of the scalar product. That is V dot W. And so what we do is we rearrange that to say V dot W equals magnitude of V, magnitude of W times cosine theta. So cosine theta is V dot W divided by the magnitude of V, magnitude of W. All right, so what does that tell me? Well, that means that if I can find the dot product, if the dot product is 0, this whole thing is going to be 0. And the cosine equaling 0 means the angle is 90. If this is negative, then we know that the angle is going to be obtuse because we're in the second quadrant, if that makes sense. So if we go back to our first example, this minus 4, what that tells me is that I'm going to have a cosine theta that's negative, and that means I'm in the second quadrant. So I know that the angle between them is obtuse. If it's positive, it's acute. It's an acute angle. So that's what the sort of premise is behind the dot product and the vector product. Okay? So you don't really need to know too much about it, other than you can use those two formulas to find the angle. So you can start out with things like this. So 2D, I don't know where it came from, but we'll just pretend that's not there. If these two, what you'll see is a questions like this that'll say these two vectors are perpendicular, all right? So the angle between is 90 degrees. When you say that, it means that the dot product is 0. So you take t times 3 and minus 4 times t plus 2 and add them together, and you know the result's going to be 0. So we're going to say R and S are perpendicular, right? That's where I'm getting that from. Just so you know, I'm not just, that's supposed to be a U. All right, and we say if that's the case, these are true, then what's T? And you'll notice you can solve then for T, all right? And the other thing that you're going to be asked to do is just, here's two vectors, what's the angle between them? Okay, so if you get two vectors and you end up with their dot product being 0, so AB is 0, 4, and AC is 5, 0, the dot product is 0, you can say the angle is 90 degrees. Otherwise, you just do the arc cosine. I'm trying to find an example where it actually, there we go. So this one actually gives me the angle and says, what's the dot product? So you can go through a bunch of examples of scalar product stuff, and we will. I'm not sure. I think I have, it doesn't look like I have any. I was hoping that I had some IB questions here at the end, but it looks like I don't. They're all from your textbook. So we'll do some of the textbook questions in class as well. But that's the concept of the scalar product. So there's really two things you can do with it. You can find components if you know that they're perpendicular, or if you know the angle that's between them, or you can find the angle that's between two vectors based on their dot product. So if you know the two vectors, you can find their scalar product and then use that scalar product to find the angle between them. So what we're going to do, we'll practice these questions. There's a bunch of these questions here in class. And hopefully by the end of those questions, you'll have a pretty good handle on vectors and their scalar product, right? So we'll leave it there. We'll see you tomorrow.